So the next thing we need to talk about is something called a mathematical model, something we've already started doing, but we haven't explicitly talked about what it is. So a mathematical model is a description of a system or phenomena using mathematical functions, graphs, equations, tables, and descriptions, to represent a real-world situation. So that's something we were doing with our ice cream shop. We were representing something that could happen in the real world mathematically. Some of the functions we look at, we just look at the functions in isolation. We don't have a situation attached. But a lot of times we do have a situation, and that's why we want to get good at this modeling, so we can figure out a way to generate functions that model what's happening in the real world. So let's consider the following. A popcorn vendor at Fenway sells popcorn for $6 a bag. Let R be the revenue in dollars for one night sales, and P represent the number of bags of popcorn sold. The vendor's revenue can be modeled by R equals 6 times P. So here we have a situation where a vendor at Fenway is walking around and selling popcorn. The amount of money that vendor takes in every single night depends on the number of bags of popcorn that is sold. And since it's sold for $6 per bag, that's where we get that 6 times P. So $6 for each bag. So if we sell one bag, the revenue would be $6. If we sold 2 bags, the revenue would be $12. So revenue is the amount of money that you take in from selling something. So here, if we wanted to talk about the independent and dependent variable, we would need to figure out which variable we would be plugging numbers into, which one varies over time. And so here, my independent variable is going to be P, which represents the number of bags of popcorn sold. So here, it can vary from 0 bags up to who knows how many bags. But that's the number, and that's the variable where we're going to be plugging in our inputs. So here, my independent variable, which I'll write as IV, is P. And my dependent variable is going to be revenue, or R, because my revenue depends on the number of bags that I sell, P. For part 2, we want to consider if this function is continuous or discrete. So here, if we want to know if something is continuous or discrete, we really need to consider what's going on with our independent variable and what types of numbers we can plug into it. So here, popcorn, it makes sense that the types of numbers that we are going to be plugging in are going to be integer numbers, things like 1, 2, 3, 4. It doesn't make sense to plug in something like 1.5. The vendor cannot sell 1.5 bags of popcorn because popcorn bags are individual units. So in this case, this function is going to be discrete because the types of numbers that we can plug in are set numbers and we can't plug in numbers between them. For part 3, we want to find a way to identify the domain and range for this function. So again, let's start with the domain. So for the domain, we're talking about values that we can plug in for P. Since it's a discrete function, we're going to use the squiggly brackets and we're going to list them. So the number of popcorn bags could be 0, right? If it's a bad night, maybe it's raining and no one wants popcorn. It could be 1, 2, 3, 4. Now we run into a little bit of problem because I don't want to keep writing numbers on and on and on for hours and hours because that would be really terrible for both of us. So in math, we have this convention where if we want something to continue, we can do ... Okay? And so here, if I write ... and I don't write an endpoint, that means technically it could go on to infinity. Now, we probably both agree that we're not going to sell infinitely many bags of popcorn, but we don't know what the upper limit is. There's not enough information in this problem to tell us what the restriction is on the upper bound of popcorn. So for now, I'm going to leave my domain as ... to say that those numbers will continue as integers as they go along. The range for the function, revenue, again, is going to be generated by considering what R values we can get from plugging the P values in. If we plug in 0, if we've sold 0 bags of popcorn, the revenue will be $0 because 6 times 0 is 0. If we plug in 1, I get 6 times 1, which is 6. If I plug in 2, I get 6 times 2, which is 12. So I can see here that I have multiples of 6 in order. And again, I'm going to use ... to indicate that that's going to continue going on. And again, I was taking those p-values and I was plugging them into the function r equals 6p, because that was the function that modeled our situation here. So we can take these real-world problems and still talk about the types of things we were talking about before in terms of functions.